This week I was working on my pose recognition software, and these are the things I want to remember. That way I don't have to relearn them when I come back to this in the future. So this is going to be in the opposite order of how I solve these. But first up, we're going to talk about normalizing data and what we're looking for. So we got to make sure for this model it was 0 to 255 is with the normalized pixel data. So it's 256 by 256 times 3, and then the values of 0 to 255. You can't just blindly trust what the LLM tells you. You got to know what you're looking for. The LLM said to divide by 255, and at the time I didn't really think about it, but it took a lot of time to get things working after that. That's because this model is expecting 256 by 256 by 3 pixels deep, and then the normalized data is going to be 0 to 255. Now if it was 0 to 1, this would have worked out great, but it wasn't. And so that's why you got to know what the model is asking for. Drawing into the canvas is really simple. It's a one-liner, and the hard part is you can have a normalized value of 0 to 1 or 0 to 255, and that was a real problem for me understanding about the normalized values of the model, and it confused me. Alright, and we have some bonus stuff. How to set up a button, what the syntax for that. This is important because you can't put the action on the HTML because they're two separate documents. It's pretty simple. It's on screen right now. You have to add an event listener in the JavaScript, and this is just really a function that gets called whenever the event happens, and it replaces needing to put an on action in the HTML. Set interval is very useful for running your model at a consistent frame rate. The only problem is if you have a memory leak and you don't know it, then it will just cause your program to eventually crash. So how do you know if you have a memory leak? Well, there's this one line you can run along with your loop and see if it's catching everything. And it's on screen right now. It tells you the number of TF tensors that are in memory. And if it keeps growing, you got a problem. But if it stays the same, you're good. And the biggest problem, I don't know where they spawn from, because it could be the functions, but I was just having problems, so I just put everything in a TF.tidy function. Here's the syntax for that as well. And this just makes it really easy because you don't have to know when a tensor is being created. You can just eliminate them at the end of your thing.